Hello, welcome back. How do we solve this exponential equation? So we have 9 raised power x minus 6 raised power x equals to 4 raised power x. So let's divide both sides by 4 raised power x. So doing so, we have 9 raised power x over 4 raised power x minus 6 raised power x over 4 raised power x equals to 1. Because this guy cancels this guy, so we're going to have 1 on the right hand side. But this guy, we can rewrite it as 9 over 4 raised power x. Likewise, this guy has 6 over 4 raised power x equals to 1. We just pull out the power, which is x. So let's simplify this guy. 9 can be written as 3 square. Likewise, 4 as 2 square raised power x minus. So 6 divided by 4 can be written as 3 over 2 raised power x equals to 1. So in this case, we are going to pull out the power 2. So we're going to have 3 over 2 raised power 2 times x minus 3 over 2 raised power x equals to 1. So the next step is that we are going to switch this guy, x and 2. So we have 3 over 2 raised power x times 2 minus 3 over 2 raised power x equals to 1. So let k to be equals 3 over 2 raised power x. So anywhere we see 3 over 2 raised power x, we just replace it with p. So we're gonna have here p square minus p equals to 1. So let's write this guy. So we're gonna have p square minus p minus 1 equals to 0. But this guy it is not factorizable. It's not factorizable. So we're gonna use quadratic formula. So p will be equals to minus b plus or minus square root of b square minus 4ac over 2a. So the coefficient of p square is 1, the coefficient of p is minus 1, and c will be minus 1 because it's just the constant. So let's plug these values here. So we're going to have p equals, b is minus 1, so we have minus into minus 1 plus or minus. In place of b, we have minus 1 all square minus 4 times 1 times negative 1 over 2 times a. Because value of a is 1, value of c is negative 1. So we're going to have minus 1 times minus 1, that's 1, plus or minus. Minus 1 squared, that's 1. Minus 4 times 1 times minus 1, that's plus 4. Over 2 times 1, which is 2. So we have 1 plus or minus square root of 5 over 2. So, and this implies that p equals 1 plus root 5 over 2 or 1 minus root 5 over 2. But we are going to ignore this value because it's going to give a complex solution. So when p equals to 1 plus root 5 over 2, we just plug it. Oh, sorry, I should have changed this to p since we are dealing with p throughout here. So when p equals to 1 plus root 5 over 2, so we just plug it into this assumption. So we're going to have 1 plus root 5 over 2 equals what? Equals 3 over 2 raised per x. So equals 3 over 2 raised per x. So let's put this in bracket. So now let's take the natural logarithm of both sides. So we have log 1 plus root 5 over 2 equals log 3 over 2 raised per x. So this guy, we can rewrite it as x times log 3 over 2 by using this property. That is one of the rules of logarithm. That is, whenever we have log a raised by b, is simply the same thing as b log a. So we just use the power to multiply the whole logarithm. So equals this guy, which is log 1 plus root 5 over 2. So let's divide both sides by log 3 over 2. So we're gonna have log 3 over 2 cancel log 3 over 2. We have x equals log 1 plus root 5 over 2, everything over log 3 over 2, which is the required solution. So that's it. Thanks for watching.